Student Council sells Candygrams at a price of $4 each, and they expect that if they increase the price by 50 cents, they lose 20 Candygrams of sales. So this is a revenue problem. So it says write the equality that models this situation, define your variables. So we're going to set it up this way. So the revenue equation is revenue is equal to price times number of items sold. And we're going to set it up this way. Our revenue in terms of X is going to be the original price of $4, and we're going to do increases of 50 cents. So plus 0.5x, where X represents the number of increases of 50 cents. And we could also have 20. Sorry, it's going to be, we start with 400 as our number sold, and based on this pattern it's going to go down by groups of 20 based on our groups of 0.5. So X represents, so we're going to make our let statement, let X equal number of 50-cent increases, or we could also define this as the number of 20 Candygram decreases. So it's 50-cent increase. Okay, so there's our equation. So that's part A. Part B says, suppose the Student Council needs a revenue of at least $1,800. Solve an inequality and find the possible prices that will achieve this fundraising goal. So for part B, we need at least $1,800. So our revenue equation must be bigger than that. It's going to be 4 minus 0.5x and 400 minus 20x, sorry, plus 0.5x and minus 20x. Okay, so I'm going to expand this out. So I end up with 1,600. We're going to end up with 200x minus 80x, so plus 120x. And then multiply the last terms together, we get negative 10x squared. Okay, so there's our inequality. And says solve the inequality as well. So I'm going to solve this inequality. So I know that my sales is going to be, this is an upside down parabola, so we know that if I want to be above 1,800, it's going to be between 2 points. So if I imagine what the graph looks like over to the left here, I know I need to have that area there. So when I solve the inequality, I can check to see that my x's are in between those two values. So I'm going to solve for this where it's equal to first. So I end up with negative 10x squared plus 120x minus 200. Okay, I can factor this out. I have negative 10x squared, so I'm going to have negative 10x minus 12 plus 20. Okay, so there's my inequality, and I can probably factor this quadratic. I've got my x in here. I can factor this quadratic, so I'm going to solve it by factoring. Minus 10 minus 2 will give us our factors. So x is going to be equal to negative, or is going to be equal to 10, or 2 and 10. Okay, so that's our x values that we have here. So our x values are going to be between 2 and 10. that means we still need to find the price. I think the question does ask us about price. So what prices will achieve these fundraising goals? Okay, so we know that X has got to be between 10 and 2, and at least means we need to be equal there, but I still need to solve for the actual price. So the price that gives us that revenue, we need to base it on that price equation. So the price that we calculate, we have to plug X is 10 into that expression. So when we plug X is 10, we end up with 4 plus $5, 4 plus 5, so we end up with 9 as our upper bound, okay, for our price. And we plug in the 2 for X into that price equation. It's going to be 4 plus 0.5 times 2, or $5. So we know that the left hand boundary is going to be $5 and the right hand boundary is going to be $9. So between $5 and $9 will give us that kind of revenue.